Okay, let's take a look. We're asking the question, how do you know if a compound is chiral or achiral? Make sure that you've looked at the video that explains why we care about this. We're wanting to know about enantiomers, the type of isomer called enantiomer, and we can explain that in terms of chiral or achiral. So this video will just give us practice on identifying if a molecule is chiral or achiral. Chiral means that there's at least one carbon where all 4 bonds go to 4 totally different groups. I'll show you an example of a carbon that's not chiral. This one right here. This carbon, I can see right away that 3 of its bonds all go to hydrogen. Those are not different from each other. H is the same as H is the same as H. So this carbon right here is not chiral. This carbon right here, it might be a little bit tricky to remember what this stands for, but you know or should know that this is the abbreviation for the carboxylic acid functional group, like this. That's what that is abbreviation for. So this carbon right here is not chiral. 2 of the bonds go to the exact same place, oxygen. So this is not chiral. This is not chiral, but have a look at that carbon, that middle one. This carbon right here, here's how I'll do it. I'll say everything above it is this. That's what one of the bonds goes to, that group. Everything to the left is this. That's another group. Everything to the right is this. That's the 3rd group. And everything below is the 4th group, hydrogen. Those 4 groups are all 4 different. And what that means is this carbon is chiral. And if you have anywhere in the molecule, if you can find one carbon that's chiral, then we can say the entire molecule is chiral. The entire molecule is chiral, and what we saw in the previous video is this. Since the entire molecule is chiral, this means that this molecule and its mirror image, they are different. They, what should we say? They exist as a pair of enantiomers. So this is why we wanted to know about chiral. If you can find out that the molecule is chiral, that means that this molecule right here is different from its mirror image. They're different. Your body will treat them differently. They exist as a pair of enantiomers. This is the amino acid alanine. This is in your body right now. Your body only can recognize and use one of those not both the molecule and its mirror image, just one of the enantiomers. It knows the difference and it only will use one. That's very, very common in nature. How about this molecule here? Do you think this molecule is chiral? Let's have a look. There's 2 carbons. This one is definitely not chiral because it has 3 H's. This one, let's take a look. One group is bromine. One group is methyl. One group is H, and another group is H. So, not chiral. It does not have any chiral carbons, so this whole thing is not chiral. It's achiral, which means it will be identical to its mirror image. It's identical to its mirror image. It does not exist as a pair of enantiomers. There is no enantiomer because it's achiral. It's quite common for molecules to be chiral. Remember, we said you only need one carbon. You only need one carbon to be chiral for the whole molecule to be chiral. A tiny molecule like this had only 2 carbons to look at, but it's much more common to have lots of carbons. Biological molecules are often big, and usually there's 1 carbon in there that's chiral. So it's quite common for biological molecules to be chiral. And it's pretty common for there to be more than 1 chiral carbon. Here's an example right here. This carbon that I'm going to highlight, the 4 groups attached are this, 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 and this. So since all 4 groups are different, that yellow highlighted carbon is chiral. But you should convince yourself that for the same reason, this pink highlighted carbon is also chiral. If I were to draw a box around its 4 groups, I would get this H, this OH, this carboxylic acid, and all this stuff. So the 4 groups on the pink carbon are different, which means both the yellow and the pink carbon are both chiral. I only needed to find one to be sure that the entire molecule is chiral, but I want to show you that often there's more than one. How about here? None of these carbons are chiral. As soon as you see a double bond, it's over. That carbon cannot be chiral. When there's double bonds, that carbon cannot be chiral. And all these carbons have a double bond. When you have CH3 or CH2, that carbon's not chiral because the H's are the same as each other. So we're down to these last 2 carbons here. This yellow carbon, definitely all 4 groups are different. H, OH, all that stuff in the benzene ring. And let's see, the pink one is also chiral. H, that stuff, methyl, and all that stuff. So this also has 2 chiral carbons. We only needed 1, but it has 2. This is a chiral molecule. Here's glucose. Again, the top carbon is not chiral because the double bond. The bottom carbon is not chiral because 2 H's. But now that you've been getting some practice, convince yourself that all 4 of those yellow highlighted carbons are chiral. Again, the way you do it, let's say we're going to look at this one right here. All 4 of these are chiral. I'll show you how you can tell using this as an example. You would do it this way. Everything to the right, that's OH. Everything to the left, H. Everything above, that stuff. Everything below, that stuff. All 4 are different, so this is chiral. So notice, don't just look above and say, oh, carbon, carbon, those are the same. You're looking at the entire group. Chiral carbon, there's actually 4 chiral carbons. The entire molecule is chiral. Again, you only need 1. Last example here, CH3, nope, not chiral. This carbon right here has 2 methyls, so it's not chiral. This carbon has 3 H's, not chiral. This carbon has 2 H's, not chiral. All of these have a double bond, not chiral. This carbon right here looks promising. Let's see. It has methyl. It has that. It has that. It's only showing 3. What is the 4th one? Of course, it's H. That's our 4th one. All 4 bonds are different, so that yellow carbon is chiral. And that's actually the only chiral carbon. This one is not chiral because the double bond to O. This one is not chiral because of the 3 H's. But notice it's very, as we said, very common for biological molecules to be chiral. This is ibuprofen, which is Advil. When you eat an Advil, you're eating this and its mirror image. And only one of them is helping with your headache or sore back or whatever. This is glucose. Your body can only metabolize this if you have the mirror image. It does nothing. Doesn't taste sweet, doesn't have calories, it just goes right through. Your body cannot process it. So your body definitely knows the difference between the molecule and its mirror image. Now in our last video, let's just see a couple of examples of enantiomers.